Welcome to the Explainer. So today, we're going to embark on a truly fascinating journey. We're starting on a massive macro level, looking down at our planet from the very edge of space, and then we're going to slowly zoom all the way down into our own backyards to really understand the physical rules of our world. We'll be unpacking the grand systems that dictate our daily weather, our changing climate, and how every single one of us fits into that giant puzzle. It is an incredible story of balance, disruption, and power. Let's get into it.
Picture a planet from above, and you'll notice this incredibly thin, glowing band separating the surface of the Earth from the dark void of space. That right there is our atmosphere. It's essentially an invisible, protective blanket of air held close to the planet by gravity. Now, it might look a little fragile from way up high, but this incredibly dynamic layer of gases is the only reason life on Earth is even possible. It provides the oxygen we breathe, it acts as a shield against harmful solar radiation, and it regulates the temperature of the entire globe so it doesn't get too hot or too cold.
I want to pause right here and ask you, can you imagine what would actually happen if there were no atmosphere? Seriously, think about it. Without this vital mixture of gases, we wouldn't just lose the air in our lungs. We would be completely exposed to the harsh, burning ultraviolet radiation from the sun. The Earth would experience violent, unsurvivable temperature swings. We're talking freezing in the dark and literally boiling in the light. This one single question really sets the stakes for understanding the physical rules of our planet, doesn't it?
Okay, let's dive into our roadmap. First, Earth's invisible blanket. Second, the elements of weather. Third, the mighty Indian monsoon. Fourth, climate change and floods, and finally, your carbon footprint.
Section 1. Earth's invisible blanket, the planetary scale.
You know, when you look up at the sky, the atmosphere feels impossibly vast, almost infinite, but it's actually a very specific, delicate recipe. Surprisingly, the air we breathe is overwhelmingly made up of nitrogen, at 78%, which is absolutely essential for the nitrogen cycle that allows plants to grow. Then we have oxygen at 21%, which of course humans and animals need to breathe. But what's truly wild is that everything else, including carbon dioxide, argon, and water vapor, makes up just 1% of the atmosphere. Just 1%. Yet that tiny fraction of carbon dioxide is heavily responsible for trapping heat and keeping our planet warm.
Let's see how this builds, because this invisible blanket stacks vertically into 5 distinct layers based on temperature and density. Down at the very bottom, from 0 to about 12 kilometers up, we have the troposphere. This is where we live, and it's where almost all of our weather, the clouds, the rain, the storms, actually happens. As we move higher into the stratosphere, we find the ozone layer, which absorbs the sun's UV rays. Then we pass through the freezing mesosphere, up into the extremely hot thermosphere, and finally, we reach the exosphere, where the air is incredibly thin and gradually just merges directly into outer space.
Section 2. The elements of weather, the systemic scale.
So the crucial point here is understanding the fundamental difference between weather and climate, because people mix these up all the time. Weather refers to the short-term, day-to-day variations in the atmosphere, like today's rainfall, wind, or temperature in your city. Climate, on the other hand, describes the average weather pattern of a place over a very long period of time, usually decades. Think of weather as your daily mood, while climate is your overall personality.
Now, a massive driver of that daily weather is altitude. Because of a rule called the normal lapse rate, as you move upward in the troposphere, the temperature drops by about 6.5 degrees Celsius for every 1,000 meters you climb. To put that into perspective, this perfectly explains exactly why popular hill stations in India, like Uti or Darjeeling, remain beautifully cool and comfortable, even while the plains down below in cities like Delhi or Chennai are absolutely baking in the intense summer heat.
Section 3. The mighty Indian monsoon, the regional scale.
To really anchor this concept, we need to look at the word itself. Monsoon actually originates from the Arabic word mausim, which simply means season. Historically, sailors used it to describe the seasonal change in winds. And that is exactly what a monsoon is. It's not just heavy rain. It's entirely characterized by a complete seasonal reversal of wind direction, which brings totally distinct weather conditions right along with it.
And this brilliantly illustrates how it works. During the summer, the advancing monsoon pulls intense, moisture-laden southwest winds from the Indian Ocean across the land, bringing widespread heavy rainfall. But during the transition season, those winds completely reverse. In the retreating monsoon, they withdraw from the landmass and blow back out towards the ocean, resulting in clear skies and decreasing humidity for most of the country.
But here's the catch. When those advancing monsoon winds drop their moisture, they definitely don't do it evenly.
The western coast and northeastern states receive a staggering 400 centimeters of rain annually, while areas like western Rajasthan are significantly drier. This highly uneven distribution shapes absolutely everything in the region: the natural vegetation, the specific cropping patterns farmers have to use, and literally the daily livelihoods of millions of people.
Section 4. Climate change and floods. The disruption.
Unfortunately, climate change creates extreme disruption to this water cycle, pushing it in two opposing directions. On one hand, rising global temperatures lead to irregular rainfall and devastating, cracked earth droughts that can totally destroy food production. Simultaneously, those exact same rising temperatures are rapidly melting polar ice and mountain glaciers, raising sea levels and threatening coastal areas. It's a stark dual physical impact that creates chaos in both directions.
When we localize this global threat to India, the impact is severe. Around 40 million hectares of land are prone to flooding. Major river basins like the Ganga, Brahmaputra, and Godavari receive excess water from intensified rains during the monsoon season, combined with melting glaciers up north. This causes rivers to overflow, bringing severe damage to life, agriculture, and infrastructure.
Section 5. Your carbon footprint, the individual scale.
Now, what's really interesting here is how we fit into this. A carbon footprint is the total amount of greenhouse gases released directly by human activities, and it's tied to almost every single daily choice we make. Every time we use electricity powered by coal, drive a gas-powered vehicle, or even generate waste, we are actively adding to that tiny 1% of heat-trapping gases in the atmosphere, directly driving the warming and the extreme weather we just talked about.
But here is the empowering part. Because our daily actions fuel the problem, our daily actions can also alleviate it. We can actively shrink our carbon footprints right now. We can practice the 3 R's: reduce what we consume, reuse materials, and recycle waste. We can conserve energy simply by turning off lights and appliances when we leave a room. We can support a switch to renewable energy sources like solar. And we can adopt eco-friendly transportation, like taking a bus, carpooling, or riding a bicycle instead of driving alone. I want to leave you with this final provocative thought to chew on. If every single person watching this explainer reduced their personal carbon footprint by just a small amount, how could this bring about a massive, monumental change in the global environment, and why? Think about the mathematics of billions of people making one small change. The atmosphere is a shared, invisible blanket covering all of us, which means the power of collective human action to protect it is truly unimaginable. Thank you so much for joining me for this explainer, and keep looking up.